3-6, slopes of parallel and perpendicular lines. So here's a key concept, slopes of parallel lines. If two non-vertical lines are parallel, then their slopes are equal. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. That's kind of the converse of the first statement. And any two vertical or horizontal lines are parallel. So if your lines are parallel in any way, that means that the slopes are equal. They will always be equal. Parallel lines will always have the same slope. So if I give you an equation, say y equals 3x plus 7, and then y equals 3x minus 14, since m for both of these is 3, because this is in slope-intercept form, y equals mx plus b, since m in both of these cases is 3, that means these two lines are in fact parallel. Alright, because they have the same exact slope. Parallel lines will always, always, always have the same slope. Alright, checking for parallel lines. So here we have two lines in a coordinate plane, and it says our lines L1 and L2 parallel. And why or why not? So the first thing we want to do is we want to find the slope of each line. So we're going to do, they made this point 2 and this point 1. So you're going to run it through the slope formula, which remember, your slope formula is y2 minus y1 over x2 minus x1. So 5 minus negative 4, double negative turns into a positive, so 5 plus 4 is 9. Negative 1 minus 2 is negative 3. 9 over negative 3 is negative 3. Now do the same thing for the second point. Looks like they did this point 2 and this point 1. So 3 minus negative 4. Double negative is positive, so 7. And then 3 minus negative 1. Again, double negative is a positive. So 7 over negative 2, which equals negative 7 halves. Since these are not the same, alright, not the same. Since they're not the same, the lines are not parallel. Since negative 3 does not equal negative 7 halves, line 1 and line 2 are not, keyword, not parallel. Alright, in order for them to be parallel, this line should have either had a slope of negative 3, or this line should have had a slope of negative 7 halves. They would have had to have been the same number for these lines to have been parallel. Alright? You try. Line 3 contains point A, which is negative 13.6, and point B, which is negative 1.2. And line 4 contains point C, which is 3.6, and point D, which is 6.7. Are line 3 and line 4 parallel? Explain. So go ahead and pause the video and figure this out. Alright, let's see if they're parallel. So we're going to have our slope formula is y2 minus y1 over x2 minus x1. Now I'm going to make, let's see, I'm going to make this point 2 and this point 1 for the first line, and doesn't really matter here. Let's make this point 2 and this point 1 for the second line. So let's do AB first. So the slope of AB is going to be y2, which is 2, minus y1, which is 6, over negative 1 minus negative 13. So 2 minus 6 is negative 4, over plus negative 1 plus 13, which is positive 12, Pull a 4 out of the top, you get a 1. Pull a 4 out of the bottom, you get a 3. And remember, this one's negative. So the slope of the first line, AB, all right, so this is slope, slope of AB. Now let's find the slope of CD. So we're going to have 7 minus 6 over 6 minus 3. So 7 minus 6 is 1. 6 minus 3 is 3. So 1/3 is the slope of DC, or CD, however you want to write it, doesn't matter. Now, as you can see, this here gave us a negative 1/3, because you have 2 minus 6, which is negative 4, and then negative 1 minus negative 13, which is plus negative 1 plus 13, which is positive 12, because you can rewrite that as 13 minus 1, which is 12. So this gave us a slope of negative 1/3, where here we did 7 minus 6, which is 1, and then 6 minus 3, which is 3. Even though both fractions are 1/3, this one is negative, whereas this one is positive, so they are not the same. So therefore, L3 and L4 are not parallel because negative 1/3 does not equal 1/3, because one is positive and one is negative. So therefore, they are not parallel. At first it looked promising, but they are not parallel. All right, writing equations of parallel lines. So what is an equation of a line parallel to y equals negative 3x minus 5 that contains negative 1, 8? Now, since we know parallel lines have to have the same slope, just pull that negative 3 right on out. All right? So just pull the negative 3 right out, and that gives us m. And then over here, this gives us our x1 and our y1. So we're going to use negative 3 in this point. We're going to plug it into point slope formula. So it's going to be y minus 8 equals our slope, negative 3, because you just pull it straight out of this equation, equals negative 3 times x minus negative 1, which of course turns into a positive 1. So the equation for our line parallel to y equals negative 3x minus 5 is and contains this point is y minus 8 equals negative 3x plus 1. You can bring this down even further. Y minus 8 equals negative 3x minus 3, and the 8, and the 8. So y equals negative 3x plus 5. All right. So you can bring it down even further, change it from point slope to y-intercept form. And as you can see, now they look a little closer to each other to confirm they're parallel. Because here's your slopes, they're the same, and here's your y-intercepts, they're different to prove that they're two different lines. All right, so that's what you do. When you give it an equation, you simply pull out your slope, and then if you have a point here, you use point slope formula, x1, y1. If this hadn't have been a point, say this had said the y-intercept was 7, then you would have just simply basically just replace this 5 with a 7, and that would have been your equation. All right. Slopes of perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is negative 1. The converse, if the slopes of two lines have a product of negative 1, then the lines are parallel, and any horizontal line and vertical line are perpendicular. So if you have a line running horizontal, a line running perpendicular, all right, these will always be perpendicular to each other because one is vertical and one is horizontal. Now, here's something else to remember. The slopes of perpendicular lines will always be opposite reciprocals. Opposite means you change the sign. So if it's positive, it goes to negative. If it's negative, it goes to positive. Reciprocal means you flip the fraction upside down. If it's A over B, you'd flip it, it would become B over A. So opposite, you change the sign. Reciprocal, you flip it upside down. So say you had a line with a slope of 3/4. The perpendicular line would be opposite, so this is positive, so it would be negative. And then reciprocal, you'd flip it upside down, 4 over 3. All right, now this -1 thing they're talking about, if you were to multiply this together, 3 times 4 is 12, and of course this is negative. 4 times 3 is 12. 12 over 12 is 1, so a -1. Easy way to check it. Multiply them together, make sure you get a -1. But they will always be opposite reciprocals. So what happens if we had a line with a slope of -2? Well, your opposite reciprocal would be positive 1/2, because any whole number can be written as a fraction by simply putting it over 1. So now when you multiply these two together, you're going to get -2 over 2, which is -1. All right, so again, they are perpendicular. All right, so just remember, when you have a whole number, write it over 1, and then simply change the sign and flip it over. All right, so here, we changed the sign, positive and negative, and we flipped it over. 3/4 became 4/3. Here we had -2, so we changed the sign to positive, and since this is technically -2 over 1, we changed it to positive and flipped it upside down to 1/2. All right? So checking for perpendicular lines. So what you want to do, if you have a graph like this, again, you want to run it through the slope formula to find the slopes of the lines. So the slope of line 1 was -3/2. The slope of line 2 was positive 2/3. Since they are opposite reciprocals, because remember, negative goes to positive, 3/2 becomes 2/3, so they're opposite reciprocals. So that tells you right there they're automatically perpendicular. Then to confirm it, you can multiply them together. 3 times 2 is 6. 2 times 3 is 6. And then negative times positive is negative. And then 6 divided by 6 is 1, so -1. So lines L1 and L2 are perpendicular because the products of their slopes is -1. You could also tell me that they're perpendicular because their slopes are opposite reciprocals. You could also give me that for your reason. I would take that. All right. So just remember, perpendicular lines, their slopes are opposite reciprocals of each other. And if you multiply them together, you're going to get -1. And parallel lines, their slopes are equal. They're identical in every way. If you remember the problem we had a couple slides back, the slope of one was positive 1/3, the slope of another was -1/3. So those are neither parallel nor perpendicular because they're not the same and they're not opposite reciprocals. So they're neither parallel nor perpendicular. All right. Here's your ticket in the door. It says, what is the equation of a line perpendicular to y equals 1/5 x plus 2 that contains the point 15, -4? So feel free to use your notes, look back in the video if you need to. Make sure you have this answered by the time you come to class tomorrow. See you tomorrow.